All right. Welcome to this next in the series of mini tutorials on Helix. Today we're going to be talking a little bit about endpoints. So to start with, endpoints work with message federates. A message federate is a federate that allows for discrete types of events and discrete communication, so communication packets, events, controls, other things that happen in a discrete fashion. The communication on these endpoint or federates is done through endpoints. Endpoints are defined such that any endpoint can send messages to any other named endpoint in the system. Make a note here that all endpoints have a name, but some can be internally generated. So if you specify an endpoint with no specified name, one is automatically created. So it may be difficult to send something to that, but you can send stuff from it and reply to it as necessary. The communications between these endpoints are discrete, so there's single packets of data. They're not persistent, and they have a defined order to them. They're defined in order of time, then based on the source identifier for the federate that controls the endpoint, and then message index. So this is basically order of transmission. There's two APIs in the application API. The first is based on the message federate.h object itself. There's function calls in this. This uses handles to reference the endpoints. When you create them, you get an endpoint identifier back, and you need to use this whenever you send stuff from this endpoint or retrieve stuff from it. There's also an endpoints.hpp file, which defines an endpoint as an individual object. You give it a reference to a message federate, and then it just wraps that in a convenient object that can be moved around and operated on. Endpoints can also be created through API calls or through JSON file configuration. So if you give a file configuration to an endpoint or to a federate, it will make the endpoints, and then you can retrieve them later if you want to. For message federates, there's kind of two function calls, and the 2 bits of code you see there are equivalent. They will create an endpoint on a federate. For these, the name is prepended. There's also global versions of these calls where the name is not prepended. They have an optional field called a type, which is basically an extra bit of information about the endpoint, and it can specify kind of what you intend to send through this. This is optional, though, and it can be left blank. You also see a global call there, so that's what the global endpoint call would look like. And there's an equivalent one, or there's a similar version in the endpoint interface itself. Endpoints can also subscribe to publications. So this basically converts a value-based system into a message-based thing. So you subscribe an endpoint to a publication, and then any publications or any values published on that interface will get sent as messages to the endpoint. To send messages, there's a number of data formats that are accepted. You basically send it with the identifier, or in the case of the endpoint interface itself, you don't need the identifier, just send it through the object. This can be strings, char stars, a char star and a length, a data view object, which is an internal representation of different data types, and messages themselves. And you may also specify a time at which this message will be delivered. There's functions for getting the name, identifiers, types, and you can also specify callbacks that get called whenever a message is sent to a particular interface. In endpoints, so in the federate API, it's called send message. In the endpoint object itself, these methods are called send. In the endpoint objects, you may also omit a target, in which case the default target is used, and you can specify what that is. For instance, if you have an endpoint that is always sending messages to the same target, you can set the default endpoint and not worry about it. Message objects are what gets sent around internally to Helix, and these contain the data that is sent through the endpoint objects. These are the fields. So time, basically a time at which the message is to be delivered. The data, this is the actual contents of the message. Then there's a source, destination, strings. So these specify where it's coming from and where it's going to. And also original source and original destination, because messages can be modified by filters or rerouted. And we'll talk about filters in a later talk, but these fields are used in those contexts to maintain the information about the original sources and destination. Messages also have a flag and a message ID fields. These are used internally to route the messages and with filters, but some parts of it can be used externally or by users. There's a number of functions for getting messages. You can check if it has in an endpoint has a message or a federate has a message on any of its endpoints. You can get a count of how many messages are to be received, and then you can actually retrieve the messages. The messages themselves are packaged as basically unique pointer objects. We'll talk a little bit more about that later. The callbacks, you can also specify a callback that gets triggered whenever a message is received by a particular endpoint, and this will notify something and you can retrieve it or do whatever you want with it at that point. If you can, of course, try to cause problems, but the intent is to use unique pointers to manage the blocks of memory for messages. Messages can only be retrieved once, so they exist as singular objects all throughout HELICS, and once retrieved, the caller basically takes ownership of it. And that's why we use unique pointers to specify that ownership. There's two examples we have in the repo. There's a message fed and a message fed object. The difference between these two is they are one uses the message federate API directly, and the other uses the endpoint object API. And you can see the link there in the repo. So what do you do with endpoints? The intent here is to use these as the discrete event part of HELICS. These is for communication events, signals, triggers, basically anything you can think of that exists as a one-time data block and not a persistent value. So in this case, we're sending messages from a transmission level simulator to an AGC controller. So data packets get sent to the AGC controller. These could be subscribed from value messages or directly sent as some sort of data format. And then control packets are sent back to the transmission simulator to figure out what it needs to do at a particular time. And with that, I will end that quick introduction to endpoints and see if there's any questions.